Hi everyone, so we're finally finished with data representation, so we're going to move on to the next unit of computer systems, which is computer structure. Within this unit, you need to know about three new types of register: the memory address register, the memory data register, and the instruction register. And we're also going to do a big bit on pipelining, which is used to increase the throughput of your computer. Okay, I'm going to do a separate video for that one because it's a slightly larger concept. If you have a little look at your assessment as for learning sheets, you will see that the information we're going to cover this week is exactly what you need to know for this whole unit. Okay, the one bit that's added onto the bottom there is what we covered last week, which is the flag registers and their use within binary addition calculations. We did that in last week's video. Okay. So these three new registers, what are they? What are they used for? To start off with, the memory address register is linked to the address bus, and it will store the memory location of the address that you either want to save information to or read information from. Okay? As you may have guessed, the memory data register is linked to the data bus, and it will store the data that has been written to or has been read from the memory. Lastly, the instruction register is passed information by the memory data register to then be used within the processor itself. So it may be taken by the ALU or it may be used by the control unit in some way or form. Okay, so that's what the three of them are. You'll recognise the fetch execute cycle from your time within National 5 and higher computing science. Okay, just to refresh your memory, let's talk about what those 4 steps are. Number 1, the memory address of the next instruction is placed on the address bus. Number 2, the read line is activated on the control bus. Now this is obviously only in a read fetch execute cycle and not in a save or a write one. Number 3, the instruction is transferred to the processor on the data bus. And then number 4, the instruction is then decoded and executed, and that continues round and round. Fetch, decode, execute, fetch, decode, execute with every instruction your computer will do. At Advanced Higher, we're basically using the same 4 steps, but we're expanding them to be able to use these registers and explain where they're used within this process. So our 4 steps change to this. Number 1, the processor sets up the memory address register with the required address that the address bus needs to go to. Number 2, the processor activates the read line on the control bus. This is the same. Number 3, an instruction is fetched from the memory location using the data bus and stored in the memory data register, where it is then at number 4 passed to the instruction register, where it is interpreted or decoded and then given to the control unit or the ALU to have something done to it. Okay, so that is what your new operation or your new fetch execute cycle will look like at Advanced Higher. Now let's see what that looks like more practically. So here we've got a diagram of the processor, the main memory. You can see the buses running between them. And on the left, what I've done is put a little table to represent those 3 specific instructions and what they'll have stored inside them. However, you can see them here inside the processor itself. Okay, now the step number 1 is that we take the information or we take the address of the memory we want to read from and we store it into this memory address register. Okay, now I want to imagine that I'm going to read this first one here. So this is the address I'm looking for. It's written in low-level language, so don't worry too much about what it says. Okay, but 00F needs to be put into the memory address register, so it's set up. Number 2, after the address bus points towards the right place, what happens is the read line is activated on the control bus, so that it knows that when it goes to that address, it's reading rather than writing information over the top of what's already there. Okay, so the read line is activated. Step number 3, an instruction is fetched from the memory location we're pointing to. So 00F is the memory location. The data bus has to take this information here and put it into its memory data register, which is then populated in here. Okay, and then the last step, step number 4, is that that information is passed into the instruction register, so from here to here, okay, so that that can then be decoded and used by the control unit or perhaps calculated in some way by the ALU. And that is literally it. Really, really easy. That's all we need to know about those steps. I'm going to do a little quiz at the end for you guys to fill out just to see that you've managed to take all of that in. Remember to watch the video on pipelining before you continue with the quiz.